Welcome to my video for the Principles of Microeconomics class, and this is going to deal with the issue of present value that I was talking about in class, and this is the video I told you that I would post so everybody could review this for the test coming up on Monday night. Here in this cell here you can see the formula for present value, and it states that present value is the summation of the payments, PT, divided by 1 over 1 plus I to the t power. This t just signifies time. So for example, if we take a look at here, let me just do the constituent parts here. If I was referencing the payment in year 1, we have $100 in our example. Payment in year 2 is $100. Payment in year 3 is $100, and the payment in year 4 is equal to $100. So this T just signifies different points in time, and this is a 4-year time frame. The denominator is the discount factor, and it's 1 plus the interest rate to the T power. So in our example here, the interest rate is equal to 10%. So in year 1, this is going to be 1 plus 0.1 to the first power, which is just going to be equal to 1.1. In year 2, this is going to be equal to 1 plus 0.1 to the second power. So it's going to be 1.1 squared, which equals 1.21. In year 3, it's going to be 1 plus 0.1, so 1.1 to the third power. So 1.1 to the third power is equal to 1.331. And then in the last year, we're going to have 1.1 to the fourth power, and 1.1 to the fourth power is equal to 1.4641. So what we do is that for every year, we take the payment in that year. So that's PT right here. So it's 100, and we divide by the appropriate discount factor. So in year 1, that's 1.1. 100 divided by 1.1 is equal to $90.91. We do the same thing for year 2. We get a payment in year 2, so that's P2 is equal to $100. The discount factor in the second year is 1.1 squared, which is 1.21. So 100 divided by 1.21 is equal to 86.64. We do the same thing for year 3. The payment is $100 in year 3. The discount factor is 1.1 to the third power, which is equal to 1.331. So we take 100, divide by the discount factor, and we get $75.13. And in the fourth year, we do the same exact thing, $100, divided by the discount factor, which is 1.1 to the fourth power, which we already calculated as 1.4641. So 100 divided by the discount factor is equal to 68.30. So to get the present value, we have to sum the present value of each of those individual payments. What we did is we calculated the present value of that payment in year 1, the payment in year 2, the payment in year 3, and the payment in year 4. So we have to sum all those present values, and when we sum all those present values, we get $316.99. So for example, if somebody had offered to give you a payment of $300 right now versus a payment of a stream of payments of $100 every year for the next 4 years. So we get a payment of $100 in year 1, 102, 103 years, and 104 years. The present value of that payment is $316 or $317 rounded. So if somebody had offered to give you $300 right now versus this payment stream at an interest rate of 10%, you would select the payment stream because the payment stream, the present value of that payment stream is equal to $317. Let me do this again, but let me change it. Now I have this set up in a spreadsheet so it automatically calculates everything for you. Let's see how this changes if I lower the interest rate. Let's say the interest rate is not 10%, but is equal to 5%. As you can see, everything was recalculated. So let's go through and see how that changed things. These all stay the same. The payment stream is not changing. It's $100 a year for the next 4 years. That doesn't change. But what changes is the discount factor. So in year 1, Looking at the formula, it's 1 plus 0.5 to the first power, which is equal to 1.05. We take that 100, divide by 1.05, and that gives us $95.24. We do the same for the next year. We take that payment of $100 coming in 2 years from now, divide by the discount factor, which is equal to 1.05 squared. So 1.05 squared is equal to 1.1025. You take the 100, divide by that discount factor, and we get a payment, a present value of that payment in 2 years at 5% is equal to $90.70. We do the same thing for the year 3 payment. Again, it's $100, but this time the discount factor is 1.05 to the third power, and that works out to 1.157625, etc., all the way through. You don't have to go through that much detail. You could round it off to 2 places if you desire on the test. So if we take the 100 and divide by that discount factor, we get $86.38. And the final payment occurs in 4 years. We get that $100 payment. The discount factor, when the interest rate is 5% in 4 years, is 1.05 to the to the fourth power, and that is equal to 1.215506. We take the 100, divide by the discount factor, and we get a present value of that payment in the 4th year of $82.27. If we take a look at all the payments that we're receiving here, if we add all of those payments up, that gives us the present value of that payment stream. So that present value of a payment of $100 a year from now, $100 2 years from now, $100 3 years from now, $100 4 years from now, at a 5% interest rate, the present value of that payment stream is $354.60. So for example, if somebody had offered you the option of taking a payment of $360 right now versus this payment stream at 5%, you would select the $360 payment, immediate payment, because the present value of that payment stream is less than $360. It's $354.60.